directions are x, y and z, and I have I cap, j cap and k cap as the unit vectors. Of course, the angles between the x and y and y and z and z and x, they're all 90 degrees. So with that, with the definitions in our mind, with the definition of the cross product, dot product in the mind, that A dot B is equal to A dot B is equal to a resultant vector, a scalar, and that is AB cos of theta. Let me also write that the non-varying vectors I along the x direction, j cap along the y direction, and k cap along the z direction all have a value of 1. So with that, with the application of this to I, j and k, I can establish that, and you can do it in exercise. I leave it to you. I dot I is equal to j dot j cap is equal to k dot k cap, and in all these cases the value will turn out to be equal to, all these values are 1, 1, 1, 1, 1, 1, and therefore I have 1, and this asterisk is the multiplication sign I am putting here, taking the liberty 1 into 1 into cos of 0 degrees or 0 radians, which all of us know that is equal to 1. So ultimately this turns out to be equal to 1. So I can write now for this, there is a simple equation I can write, same cap same, and remember that very easily, that is equal to 1. Of course, in all these cases what we have, the I cap and another I cap, the angle between the two of them is 0. Okay, I cap and I cap. Similarly, j cap and j cap, k cap and k cap, all of them are having the same magnitude. The angle between the two of them is equal to 0. But if I say, what is the value of I dot j? I dot j. So what is the angle between I and j? The angle between I and j is 90 degrees. And cos of 90 degrees, cos of 0 is equal to 1 is equal to 1, and cos of 90 degrees, which is equal to cos of pi by 2, same value written in radians, and this is equal to 0. So here in this case I will get I dot j is equal to 1 into the same 1 into this 0, and therefore it turned out to be equal to 0. And similarly, if I go in the reverse order, j dot I, so that will also be equal to 0. So I can write this expression as j dot I cap is equal to 0. And similarly, I can take j dot k. In the cyclic order I will go j dot k or this will be equal to k dot j will be equal to 1 into 1 into this cos of 90 degrees, whether the theta is equal to plus 90 degrees or minus 90 degrees. So this will turn out to be equal to 0, and therefore the value turns out to be equal to 0. And similarly, k dot I, k cap dot I cap, which is equal to I cap dot k cap, is equal to, again the same way, 1 into 1 into 0 turns out to be equal to 0. So we can remember this like we remembered I dot I, j dot j, k dot k by same dot same. Similarly, we can remember with the simple statement that else dot else. It's not the same. Any else and any other else dot else is equal to 0. Is equal to 0. So bearing that in mind, I can now, if I write the two vectors again with these results in mind, I have only this same dot same is equal to else dot else for the unit vectors. So I'll save this here, same cap dot same cap is equal to 1, and else cap else is not the same. One else is other than the other else, so is equal to 0. This is just a way to remember the things, register the things, and then be able to take it out and use it under the situation. Now, to be a little more this thing, I'll show you as to what is the value of how we obtain the value. So allow me to rub it off. I'm sorry. And write a generalized vector A having the component AX in the X direction, AX I cap plus AY J cap plus AZ K cap, and so that my vector, the value of the scalar A is equal to AX square, which is scalar, AY square plus AZ square whole raised to the power half or under root x square plus y square plus AZ square under root. So I find if I have any numerical values given to AX, AY and AZ, then I can calculate the value of the magnitude A. And similarly, I can also write the vector B, which can be of the same species, the same family or another family, Bx, in a similar manner. By j plus bz k, so that b again is equal to, like before, in the under root bx square plus by square plus bz square. It's very simple and fluent thing which you can remember always. So now these two values I have obtained, the value of A and value of B. Now if I multiply with the with the rules of multiplication, A dot B. So what I will get is this whole thing multiplied by this thing. So I will write just as the kid does, and it's good to be a kid at this age. AY J cap plus AZ K cap. This dot BX I cap plus BY J cap plus BZ K cap. Now these are two values which have to be multiplied. So one term by another term. So I can write here that the first term multiplying with this, I will get AX into BX, these are the scalars, and then I dot I cap dot I cap plus the second term is AX into BY, AX BY I dot J cap plus AX BZ, AX BZ I dot K I cap dot K cap here, plus the second term now I take AY and multiply with all these quantities. So AY BX plus AY BX, this is J dot I, J cap dot I cap plus AY BY, J cap dot J cap plus, I'll do it like a kid, AZ BZ, very disciplined one, AZ BZ, and I have J cap dot K cap. And the third term, that is AZK, multiplying it throughout, AZ BX and K dot I, K cap dot I cap plus AZ BY, K cap dot J cap plus AZ BZ K dot K. Don't get bored. This is just being a kid. Enjoy that. Spend some time. And now what the results that we obtain are that these quantities I dot j, because this is else dot else, j dot k, else dot else, j dot I and j dot k here, k dot I and k dot j, all these quantities, they vanish. They vanish. This will vanish. This will vanish. This will vanish. This will vanish being equal to 0. And this will vanish. This will vanish. I'm sorry, this will not. This will not vanish, sir. What will vanish is this one. So what I obtain now? I am left with ax bx I dot I, ay by j dot j, az bz k dot k, and I dot I, same dot same, j dot j, same dot same, k dot k, same dot k, same, and all of them turn out to be equal to 0. So I can write that this is equal to ax bx plus ay by plus az bz. So very simple. What I have here is just, look here, in these two equations, I, j, k, I cap by j cap, k cap, they are all sort of constants. They are all invariants. They are not changing. So in that case, all I will get is simply to obtain a dot product if the values of the two vectors is given to us is just to multiply this ax bx, ay by, and az bz. So every other factor goes, and so finally I can write that a dot b is nothing but, under this condition, a dot b is equal to the component ax bx plus ay by plus az bz. Okay, and the same factor. So I can obtain the value of a, I can obtain the value of b, and therefore I can obtain the value of the angle theta, as theta is equal to cos inverse of a dot b divided by a into b. Okay, so with that I'll just stop here for the scalar or dot product and leave you or push you into the ocean like what is done with the Navy cadets, and they can find out so many problems and they enjoy this thing. But with this, that same cap dot same cap is equal to 1, else cap is equal to dot is equal to 0. So good for that. But now I take up the other thing, which is very interesting. Okay, now I am going to introduce the third kind of a multiplication that goes with vectors, and this is very interesting. Okay, not like in the case of the other product. Now I have two vectors a and b, and we have the product connotation by cross a cross b is equal to a new vector say I'll just call this vector as a vector c. So what it means, I told you that a new vector can be obtained in the case of a vector multiplied by a scalar. Like in the case of momentum, I obtained by multiplying the velocity by mass, or force I obtained as acceleration multiplied by this. Now in this case, there are two vectors, and these vectors may be of the same family or maybe from a different family. So if I have like this a cross b, we obtain a new vector c, which of course has got the magnitude of a multiplied by b. For example, if we have velocity and acceleration, then this is meter per second multiplied by and this one is meter per second square, so it is meter square per second cube. Okay, you can just work it out. But A cross B is equal to a new vector C, and let me show it to you with the help of a correlate over here. This is my vector A, and in the same plane I have a vector B here, vector B, A cross B, a new vector C, and the same my vector B is making an angle of theta, or I can say is leading the vector A by theta, but these two vectors can have different magnitudes, they can have different units, they can belong to one family, they can belong to another family. Okay, so now here what I have is that I will tell you what is the relation of this new vector where my vector C dot A is equal to 0. Also vector C dot B is equal to 0. So recall, when do I get a dot product equal to 0? When the constituent vectors, the vector undergoing the operation of dot product, C and A, C and B, or A and C and B and C in the reverse order, these we obtain a value 0. What it means? That there has to be a cosine theta which is equal to 0, and which gives us two values of this friend theta. Theta is equal to, say, plus 90 degrees or minus 90 degrees. Both are feasible, both are possible, because cos of minus theta is equal to cos of theta. So the theta turns out to be 90 degrees. And as I told you before, that which is the new thing, which is a line which is perpendicular to both A and B existing in the same plane. And we found that that line could be like this, out of the board or into the board. Okay, so here in this case, what I do is, let us try to convey to each other what is the direction of this. So in this case, A cross B, the direction will be a vector which I will obtain like this. So for this, I have a right hand, I have a set of fingers, right hand and set of fingers, and what I do is that I curl my fingers like this, and then I rotate this vector, first vector, in the string of vectors A and B towards the second vector in the same string. And what will happen? That my thumb will point outside from the board. So this new vector, my vector C, or I can just write that the direction of C cap, the direction of this vector is like this. This introduced before, and I said that this is an arrow which is coming out of the board. So C is like this. And it's the situation, look here friends, that if the situation is that suppose A was like this and vector A, and the vector B was something like this, vector B, Then in the string A cross B, I have to rotate my vector A towards the vector B through the angle that the second vector makes with the first vector, and I'll get A cross B, the sense of the new vector C. And in this case you can find that if I have this rotate like this, then my thumb points inside, and that means my C in this case, C cap, is into the plane of the board, which I can show like this. So C is a new vector. We generate a vector by multiplying two vectors A and B. So you can see, and I'll give the magnitude of the new vector C, etc. But the new vector could be obtained with the right hand curl rule, okay, or the right hand curl rule when it points inside or points outside, etc., etc. The new vector C, the magnitude of this vector C, I will rather write this as equal to A B sine of theta, so that I can write the vector C as again the same values, set of values, AB sine theta, and I will suggest that this total value be multiplied by the direction vector C cap. Now look here, whether the direction is outside or the direction is into it, in both the cases it is a normal to the plane in which the vectors A and B exist. Okay, so sometimes instead of writing C cap, some people also write N cap is standing for normal. But right now, when I am introducing it to you, I will make you understand that the vector C is equal to a new vector which is given by AB sine of theta. Now I will resort to another figure over here, and that figure I'll plot here again, and will give you an idea of what is the AB sine theta is. So I have, this is my vector B and this is my vector A. My vector A is very interesting, okay, and this is my vector B in the units of this physical quantity, vector A over here. And what I do is I complete the parallelogram. And what I have is, I have vector A which I translate and take from another point, starting point, to another starting point, and if I am okay, then this is the vector which is again vector A. And similarly, if I translate from here to here the vector B, then I have a vector B here. Okay. Allow me to extend this line. Very interesting. And then we have the angle theta here. The same angle, because they will be alternate angles in this. And if I drop the perpendicular here, and also drop a perpendicular here, these will become similar triangles. Maybe there is some drawing mistake on my part. Okay, this should have been slanted a little bit over here, so when you are making, you are able to make it better. This is the magnitude over here is B, and also the magnitude over here is B. Okay, so this is from here to here, it is B cos of theta, as I did earlier, and this one is also from here to here is B cos of, B cos of theta. Okay, this is my B sin theta, B sin theta, and this one also my B sin theta. See, these two triangles are similar triangles. They will have all, this angle will be equal to this angle is equal to this angle is equal to this angle, this side is equal to this side, etc. And now what I get is that because this is A, so you can understand and you can say that this is also A. So what I have? What I have? I have now a triangle with the length equal to A and the breadth is equal to B sin theta. Okay. So now I can say, suppose I don't have this. I don't have this part. Okay, I don't have this part. So what I have? I have a breadth of B sin theta and a length of A. This length from here to here is equal to A. And suppose in this I have a triangle here with this one as B, this one as B sin theta, and this one as B cos of theta. Now allow me to cut and paste. Cut and paste. Cut and paste. So what I get is, if I cut this and paste here, these days you know what it means by cutting, so I'll just cut this portion and paste it here. So what I have now a parallelogram. Okay, so we find that the magnitude of this vector C is AB sine of theta. This is B sine of theta, okay, the same, and this is A. So I have the area of this parallelogram over here. This parallelogram over here is equal to AB sine of theta, and of course the unit vector will be like this in this direction. So I can say that my C is equal to AB sine theta. Okay, but there is something very interesting that the area of the parallelogram which is made by these two vectors A and B in the plane in which they exist, and the units that are the product of the unit of A and B is obtained like this. And in this case, where the angle theta is positive, is an acute angle, the direction of this will be like this. So I can say that I can have the vector C with this area. Vector C will look like this. The new vector, the product of the two vectors A cross B, the new vector C, it points out of the board like this. Okay, so this is one point. Now see, as to what happens in case we have B cross A. B cross A. Okay. In the case of B cross A, I told you that if I rotate my B towards A, then I get a vector which should be inside. So B cross A will go inside, but I'll just elaborate a little bit more that B cross A will be equal to B into, now this into is a secular into, B into A sine of, what is the angle? Sine of minus theta, okay, and this whole thing multiplied by the resultant vector, which is, say, I can write C dash cap, which is out of it. So B cross A sine of minus theta. What is sine of minus theta? Sine of minus theta is equal to minus sine theta. So this is, okay, B into A, so it will become equal to AB finally, AB into minus into sine theta. So what I wish to show to you, of course, this whole thing multiplied by C cap dash or whatever you want to say. So B cross A, I can write now very simply, and I leave it here because otherwise the lecture will become very bulky today, and therefore what I just go for this thing that A cross B is not equal to B cross A. Instead I have A cross B equal to minus B cross A, or simply I can write that A cross B plus B cross A is equal to 0. So with that I will come back to you and show you how this cross product is useful, and to go ahead I'll just tell you one thing, one very simple example. And in this very simple example I have a photo frame over here which you can see here, and this is the length of the photo frame and this is the breadth of the photo frame. Okay, so if I multiply and you allow me, this is my A and this is my B, and when I do the A cross B, then what I obtain? In this situation I will obtain a vector C which is out of the board, and this is the normal which shows, and look here, area is not a vector but surface area is a vector which is obtained by a length cross another length, and this way we rotate it and then the C vector turns out. So we will talk more about it when we meet again shortly. Hope that you have enjoyed so far, and of course I will do I cross J and J cross K and K cross I, etc., etc. Okay, so that we are equipped to deal into the cross products and applies it to physical situations where R cross P or R cross F, etc. will come in the mechanics that is going to follow. So my request that before I start elaborating on this cross product, which is a very interesting part in physics, okay, I request you to go back to your books and the presentations of others, whatever you want, and try to equip yourself just to understand more about the dot and cross product, which we'll take up next time. Bye.